Chapter 2, Section 1, our objective is to understand and apply instances, counterexamples, conditionals, and biconditionals. First thing, we're just looking at patterns, and we're trying to come up with the next number in each, or the next item in each pattern. The first one is January, March, May, and you will see that we're skipping a month. January, skip February. March, skip April. May, so we'll skip June. And our next item will be July. Letter B, 7, 14, 21, 28. We keep adding 7 each time, or these are our multiples of 7. So the next one will be 35. Letter C is a little bit harder, and this is actually a famous pattern. It's called the Fibonacci sequence. And what you do is you have 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and 5 plus 8 is 13. So our next item in the pattern then, 8 plus 13 would be 21. Letter D, we have 0.4, 0.04, 0.004. So our next item would be 0.0004. And instance is just a fancy word for example. And again, we're looking at patterns. And in this dot pattern, that's our first one. Our second one would look like that, 2 by 2. Then we would have a 3 by 3. And if I asked you to find the next instance or the next example, you would just do a 4 by 4. A counter example is one example, and you only need one, that makes the statement false. So one example that makes the statement false. To find a counterexample, the first part of the statement must be true, and the second part must be false. So we are asking for counterexamples. This is red. If x is greater than 5, then x equals 10. We need it to be true for the first part, but not true for the second part. So we want x to be greater than 5. So we can pick any number that's greater than 5, but we don't want it to be 10. So my counterexample would be 6. And you could use 7, 8, 9, 11, or any of those. Letter B, if x is negative, so we have to pick a negative number, we want it to be true, then x is negative 4. Well, we're going to pick x be negative 20. That is a negative number, but it's not negative 4. Letter C, for any real number x, so any number at all, x is even, so I'm going to pick the number 9. That would be our counterexample. That is a real number, but it's not even. And D, all complementary angles are congruent, so we have to have complementary angles. That part has to be true. And we want them to not be congruent. So I'm going to say 30 degrees and 60 degrees. And a reminder, complementary angles are two angles that add to 90. The next one, we need to give an instance and a counterexample to the following. If n is an integer, then it should be n, then n to the third is greater than 0. Well, for an instance, we want it to be true. So let's pick 5. 5 is an integer. 5 to the third is greater than 0. For a counter example, we need to pick an integer. And this time I'm going to pick -2. And -2 to the third is -8. And that is not greater than 0. Letter B, if n is greater than -5, then n is positive. So the instance, n is greater than -5, then n is positive. Well, we could say 10. It's an instance, an example, one that works. And for our counter example, if n is greater than -5, then n is positive. Our counter example would be -2. -2 is bigger than -5, but -2 is not positive. And next we have conditional statements. And your parents sometimes put conditions on you. If your room is clean, then you can go out this weekend. If you get all A's, maybe you get some money. That's a condition. If this happens, then you can get something. And a conditional statement is a statement that can be written in the form if P, then Q. The hypothesis is the part that follows the word if, and the conclusion uses the word and. And in symbols, sometimes we write P implies Q. Homework done implies you can go out this weekend. Or sometimes we write it as a Venn diagram. The if part goes on the inside and the Q part goes on the outside. Example 4, we need to determine if this is true. And if it's true, we can write true and be done. And if it's false, we need to give a counterexample. So if this month is August, then the next month is September. That one is true. If two angles are acute, then they have to be congruent. That one would be false. And you could draw two angles. Those are acute. And I'm going to say this one is 25 degrees and this one is 35 degrees. Those angles are both acute, but they are not congruent. C, if two angles are vertical, then they are congruent. That is true. And D, if two angles are supplementary, then they form a linear pair. That is false. You need to find two angles that are supplementary that do not form a linear pair. And I'm going to draw those two angles. This one is 150 degrees. This one is 30 degrees. So those two, since they don't touch, they do not form a linear pair, but they are supplementary. Converse is when you switch around. With symbols, you would say Q implies P, and you switch your hypothesis and conclusion. And a biconditional uses if and only if. And the symbol there is both ways. P implies Q and Q implies P, and that is read if and only if, and sometimes we write that IFF. For a biconditional to be true, the original hypothesis needs to be true and the converse needs to be true. So it needs to be true going forward and going backwards. So if a rectangle has side lengths of 12 and 25, then its area is 300. Well, if you grabbed your calculator, 12 times 25 equals 300. So that's part's true. If these are the side lengths, then that is the area. But now we need to do the converse, the backwards. If the area is 300, do the side lengths have to be this? No. If the area is 300, it might be 30 by 10. So this would be false, and that would be your counter example. B, natural numbers are our counting numbers. So if our counting numbers, or if we pick an odd number, then n squared is odd. Let's try this. 3 squared is 9. 5 squared is 25. 7 squared is 49. 9 squared is 81. 11 squared is 121. So I would say that's true. If the natural number is odd, then n squared is odd. And I will tell you the other way, if n squared is odd, then the number is odd. That one is true. Letter C, if it's a right angle, then it measures 90. That's true. If it measures 90, then it has to be a right angle. That will also be true. And letter D, if y squared is -5, y is -5, then y squared equals 25. That's true. If y squared equals 25, does y have to be 5? It does not. That is false, because y could also equal 5.